Alright guys, now we're going to do this problem which says determine the magnitude and direction of the resultant force Fr measured counterclockwise from the positive x-axis. Solve the problem by first starting F1 and F2 and then add that force that you get to F3 to get the final resultant force. Alright, you're going to need to be very organized with your diagrams for this one. So first I want you to add F1 and F2, which we're going to do our parallelogram, which is going to be something like that, moving this force over here, and I'm going to redraw that triangle over here. Alright, so actually let me make it a little longer. And we got F2 right here. So F1 is 400, F2 is 200, and you know that the angle between F1 and F2 is this angle right here, which is 90 degrees. And we're trying to find this angle. Now this is very easy because since it's a right triangle, you can use c squared is equal to a squared plus b squared. This being c is equal to 200 squared plus 400 squared, all square rooted, would give you 447.21. So this is 447.21. But we're not done. We need to relate this force to this force somehow. To do that, we have to figure out this angle right here. You can do this easily with the law of sines. So, law of sines. Now the law of sines says that A over sine of angle A is equal to B over sine of angle B, which is equal to C over sine of angle C. If you plug in the numbers, you can do 447.21, this one right here, over the sine of 90, which is this one right here. Sine of 90 is equal to 1, so you can scratch that off. Dividing by 1 is redundant. Is equal to 200, this one right here, over the angle we're trying to figure it out. Let's call it, I believe this Greek letter is epsilon. Sine of epsilon. So if you solve for this angle, is equal to 26.56 degrees. You gotta try and draw it much better than I'm drawing it. So you know that this angle is 26.56 degrees, and you know that this whole angle is 90. So the angle of your force and force 2 is going to be 90 minus epsilon, which will be this angle right here, 63.43 degrees. You know that this angle right here is 60 because this angle right here is 90. Since the whole thing is 150, this is 90, this is 60, this is 63.43. Now that I have all this information, I'm going to redraw that segment. This is the force you just calculated, which we'll call it F prime, which is equal to 447.21. This is the third force that we're supposed to add to this force, which is 300. And we just figured out a bunch of angles that adding them up will allow us to figure out this angle right here. Now look, we got 63.43 right here, plus 60 plus 90. So this is 63.43 plus 60 plus 90 If you add all of these up, actually, let me put it that way too. That's the x-axis. I believe you're gonna get, so 60 plus 90 is 150 plus 63, that would be 213, right? 0.43. Let me do that again. 120, yeah, you get 120 plus 90 is 110 plus 343 is 213.43. Now, since we know this angle and we know this force and this force, we can redraw this force to do our parallelogram. We're going to get a force more or less this way. If we draw a line straight up over here, and we have 213.43 is this whole angle, but we know that the straight line is 180. In other words, this angle is 180. So if we subtract this 180 from this, we're gonna get this angle right here, right? If you do that, you're gonna get that this angle is 33.43 degrees. If this angle is 33.43 degrees, this angle is 33.43 degrees as well. And you know that this side, which is this redrawn over here, is 300. And we got F prime. So whenever you have two forces and the angle between them, and you want to figure out the third force on a triangle, all you have to do is the law of cosines. Remember, you know two sides and the angle between them in a triangle? Law of cosines. That's simple. Law of cosines says that c squared is equal to a squared plus b squared minus 2ac cosine of angle c, which is the angle between them. So 300 squared plus 447.21 squared minus 2 times 300 times 447.21 times cosine of 33.43 degrees. You solve all this and you square root it and you get C, which is equal to the final resultant force that we're trying to find, which is equal to 257.03 newtons. Now, we know the force, but we need to know the angle between the resultant force and the x-axis. Let me draw this right here. Okay, so we know that this whole thing, you know that this is 33.43 right here, and you obviously know that this is 90. So if we could find this angle, we could actually find this whole angle right here that we're trying to find. So to figure out that angle, we're going to use the law of sines. Law of sines that I explained before. Just plugging the numbers in. We're going to do 257 over sine of 33.43 degrees is equal to 300 over sine of, let's call this angle theta. So if we solve for theta, you're going to get that it is 40.02 degrees, roughly 40 degrees. So to find the angle between the x-axis and the resultant force, let's call it that angle phi, we're going to add theta plus 33.43 plus 90 degree that the y-axis forms with the x-axis. We're going to get that phi is equal to 163.45 degrees. That's 90 plus 33, that's roughly 123.43 plus 40, 163.45 degrees because it's 0.02. Okay, perfect. and this is the magnitude. And this is the final answer. For this kind of problems, remember, try to be very organized with your drawings. Try to draw better than I do it, and make sure to draw them big so you can write as many notes as you can on your drawing.